SOAR is a student-led high school enterprise team specializing in ROVs, remotely operated vehicles. Founded in 2010, SOAR allows students to acquire skills in areas such as coding, design, wiring, additive and subtractive manufacturing, and troubleshooting. Each day, we take on challenges where failure happens often and in front of peers. We rise to meet team goals and learn through our mistakes to benefit our local watershed. Today, we will be talking about our new CompactROV and our demo ROV. Hi, my name is Maggie Gaunt, and I'm working on our new CompactROVs. We started this project to replace our current service ROVs that monitor invasive species at Isle Royale National Park. Although we thought they were at the end of their service life, with a few adjustments in 3D printed parts and batteries, they're still performing well. Now the new CompactROVs will be used as exploratory ROVs for inland lakes and abandoned underwater mines. Our new CompactROVs have smaller thrusters to allow for more efficiency, as larger thrusters couldn't function to their full capacity. Smaller thrusters allow us to use smaller ESCs, electronic speed controllers, that take up much less space in the tube. We also have new batteries that reduce resistance and weigh less. Those batteries are secured in tubes with 3D printed dovetail connectors to allow for easy replacement and charging. My current focus has been on our new camera system that eliminates the need for an expensive plastic dome that's hard to work with. Our first new system fits an inexpensive clear tubing, removes the unused pan feature, and includes a team-designed mounting system. That system took up a lot of space, so I set out to revise it. The revised camera system takes up much less space, it's easier to 3D print, and has all of the features of our original fix. As you can see here, the servo is secured to the 3D printed part as well as the camera. That allows the camera to rotate. It took a lot of trial and error while 3D printing, as layers of plastic tend to squish out a little. That squish increases the dimensions of the part a little bit. Of course, when your part is as small as this, that squish is pretty significant. I adjusted the dimensions of the part to account for the squish that happens. Another issue with the camera system was the security of the servo. In order for the servo to actually tilt the camera, the servo has to be secured so it doesn't just spin itself. I created a 3D printed tray that the servo is fastened to. The end of this tube will have a backplate just like this with 4 Deutsch connectors epoxied in. Right now there's only one. This Deutsch connector in the plate slides into a 3D printed connector on the tray. That secures the tray, which in turn secures the servo, so only the camera will spin. This part also needed adjustments to account for printing variability. I originally printed the connector separate from the tray to test the connector's fit itself. When I finally decided to print it together, I had to figure out which direction to print it in. I decided to print it vertically like this, but since I was printing it vertically, I had to add this gradual incline that goes up to the connector. If there was no incline, then right here, the printer would start printing in midair, which never ends well.
Hi, my name is Jonathan Caskey, and I'm currently working on the MiniDemo ROVs. The whole vision of this project is to make an ROV that kids can drive around in a little tank during community events. That way kids can get a taste of what they do during STEM as they get older. This means you have more kid-friendly controllers that they're familiar with. We are planning to use a Nintendo Entertainment System or NES controllers that require programming. We also been working on organizing the control box so it looks aesthetically pleasing. You'll hear more about that later. But the challenges I'm currently facing is the buoyancy. The ROV is too buoyant, so we're making a attachment, which you can unlatch that, and you can put pennies inside of it to weigh it down to hopefully get it to be neutrally buoyant. Another problem I ran into is printing these motor mounts. There has to be support for it, like this, so it can actually print, because you can't print things in the air. But with the program I was using to slice this, it did not print the supports correctly, so I had to find a whole new slicing program to successfully print these.
Hello, I'm AJ Dotto, and I'm working on the NES controllers to operate the MiniDemo ROVs. Jonathan pretty much summed up our goal for this project, but I thought I'd talk more about the controller programming and setup process. The NES controllers are programmable using an Arduino Uno board on the Arduino programming software. Once the controller and Arduino are hooked up, they will be attached to a breadboard along with 3 shields. The breadboard will be powered by a 12-volt battery, and the Arduino will be powered by a 5-volt source. Some struggles I have had with this project are both with the programming and the shield making. These struggles include getting both of the forward and backward motors to work together. Now, if you want to go to the left, you want the right one to go forward and the left one to go backward, and then vice versa. Now, the shields themselves, they need to be milled, so I had to learn how to use the CNC mill and how to use the right tape technique, and then how to get it not to cut too deep in there. A too deep of cut will damage the drill bit, and the incorrect tape technique will have the board disconnecting from the clamp before you're even done milling it. And the reason we're putting NES controllers on our ROVs is because this is way more familiar than using something like this to control an ROV.
Hi, my name is Brandon Thomas. This year I've been working on a driver station for ROVs. This consists of affixing batteries, Arduinos, and such into a box so that it can be carried without the parts getting jumbled inside. My first objective was to design a clamp for a controller so that it could be easily stored and removed without it falling out in the box. I 3D printed a part that could successfully hold the part without it falling into the box. The next project, which I'm currently working on, is a way to install batteries to power the screen in ROV. I originally intended to use a rubber fastener on the hollow floor to install the clamps, but the space was too shallow and the fasteners pushed on the bottom and back out of the hole. After many attempts at solutions, my current and most viable option is to put 3D slips, which look like this, under the floor, which may be connected to the battery clamps by a screw, which clamps the battery clamp onto the box.